Hello, hello. If you can hear me, let me know in the chat. It's a little bit quiet. That looks all right, I think. So if you can hear me, just say something, hello or whatever in the chat, and then we'll get started shortly. I need to turn that off. Cool. So if you're here, just say something in the chat. This is how it works. And then we will get into a couple of things. So I've got a couple of things to talk about. Since that, and just testing. So if you're here, just say some in the chat. I'll just wait till we get some responses and then we'll start. We've got one person here. Cool. We'll just wait for a couple more. I was hoping to go over some exam stuff, but I don't think we've got many people. Go over that. All right, so I might just start off talking about this week's lab. And then we'll continue from there. So first things first, if you were in the lab this week and you were with me, I would have talked about the preprocessor. So basically what that means is we've got some file with our C code, okay, blah, 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 and you're writing it. And then you go and compile it. So what happens here is your code is passed through the preprocessor. And then we get another bit of code, which is actually still C, okay, which is your modified C program. And then from there, we get our code compiled and we get object code, which we don't really care about. We can just think of that as our executable. Okay. So we've already seen this week how our macros act with this preprocessor. And how our if-def, okay, so we saw if-def, we've seen hash define, and we've seen these directives work through this this preprocessor. Okay, now there's more of these, like you've got hash else and things like that, and you've got ndif, which we saw this week, and so we can do a whole bunch of different stuff with these. But one that we didn't talk about this week, which we've looked at since week 1, but we haven't really talked about, and this is our hash include. Okay. So basically this is the file inclusion directive. Okay, so let's go have a look at just a little bit of code. Let's say I've got the code int main, int a becomes 4, int b becomes a, return 0. So if you're there in the chat, do we need hash define standard IO. Hash include, sorry, hash include standard IO. Do we need that here? If you don't know, just say don't know. We got a bit of a delay. I'll give you a second. Okay, so basically here, for this program, we don't actually need the standard IO because we haven't got any standard input and output. So printf and scanf are defined in our standard io.h as their function prototypes. And then you'll find somewhere else where all the standard libraries are stored, you'll find a standard io.c, and that will have the definition of our printf, etc. The return 0 is part of the C language. It's not part of standard IO. It's our input and output that's required for standard IO. So let's go have a look at something else. So we have our program, okay? And we'll also have this standard IO, which will have a bunch of other files which will define a whole bunch of different things that we can use. We have our math.h, which also will have all the definitions. And we have all of these different files that can support our program. Okay. Now, basically, what's helpful here is that when you're designing a program, we can do the same thing. So, for example, let's say you're designing a program that communicates, let's say it's an ATM machine or something. You might have some of your code that might be controlling the whole thing, so your main code. But then you might have all your networking in another file. And then you might have all your security functions in another file. Okay? And by doing this, we can group related functions together and logic and variables, and we can improve the structure of the code. Rather than having some code that's 50,000 lines long, we can break it up into little pieces. The other thing is that we can test each of these individually and target which one has the problem. Okay. The third thing is that we can reuse these. So this was an ATM machine, but then you go and do some other, let's say some web thing, and you need this security, you can use this for both of these. Okay, so by having multiple files, this can definitely help. The other thing is that it allows us to reuse other standard libraries and also open source or purchased libraries. So for example, if you're working on some complex mathematics and you need to buy some code, you can just include the header file and the C file rather than having to copy and paste it. Okay. So yeah, we can do some exam revision. We won't do much. We'll have a full stream for that before the exam, but we can do a little bit of exam stuff if we want. But let's go over this first because this is the lab this week. But yeah, I plan to do a 10-hour stream before your exam, as long as everyone's kind of actually working. All right. So the next thing is our hash include. So it can have two forms, okay? The first one is this, okay? The second one, I already spent 2.5 hours on assignment 3 last week. Yeah, I'll spend that amount of time. As long as people want to show up and actually, it depends. All right, I'll talk about that in a minute. Hash include my header dot h. Nearly did the wrong thing there. All right, we'll talk about the exam and stuff after we finish this, and the assignment 3. Why is my eraser not working? What is going on? Okay, my eraser doesn't want to work. All right, my header.h. Okay. Now, with the angle brackets here, okay, this basically tells the compiler that the header file is in the location where the standard libraries are, where this one says relative to your current directory. So this one's right next to your code. If you did an ls, you should see your code and your header file in the same spot. Okay. Why is my eraser not working? Okay, for some reason the eraser is not working. So we'll have to deal with that. Do it this way. Do it manually. Okay. So we now are going to continue and have a look at defining our own stuff. And this is fairly simple. It won't take very long, but you'll need it for this week's lab, and it will be helpful in the future if you are going to use other files and stuff like that from other people, or you're going to purchase code for your use. So first things first, let's say we've got a bit of code. Yeah. So int main, blah, blah, blah. And in this code, I want a bunch of macros, but I don't want to put all my macros here because I want them to be standard definitions. Okay. So for example, I might create another file called my macros.h. Okay. And in there, I might do hash define yes as a 1 and hash define no as a 0. And then in my code, I might go int a is yes. And then I might go if a equals yes, do something. To do this, I can include my header file, my macros.h. Okay, so you can see quite clearly that you can have a whole collection of macros in here, and you can use them however you like inside of that code there. Okay? So this is really, really handy because often we'll need to do this. Now, further from this, what I also want to do is I want to be able to share functions. Okay, so I want to be able to create some files where I can put all my functions in it. So this is getting annoying. Sorry, my pen is not working. Let me do this. Actually, let's just write a new one. All right. So what we're going to do is we're going to write a header file and a C file to support our main, okay? And this means that I can include this header file wherever I like. Now, this is what you need to be careful about. Okay. So here I've got my header file. Okay. And I'm going to call it useful functions. Okay. .h. Now in here, I can't actually write code because it's not a C file, but I can write function prototypes, I can declare variables, and I can define macros. So I'm going to create a function prototype, int is upper case. Yeah, and then it has a car. Oh, this is getting annoying. We'll call it car input. Okay, so just like your function prototypes earlier, but it's in a H file. Then we're going to create a new file. Okay. And in that file here, what we're going to do is we're going to hash include quotes because it's local, useful func.h. Okay. And then in here, we're going to define our function. Int is uppercase. I forgot to, we'll call this useful func.c. Is uppercase, car input. Okay, and then we can write our code. So our code here would be something like if input is greater or equal to A and input is less than or equal to uppercase Z, then let's say we return 1, else return 0. Okay. Now, this here can now be used in any of our programs. Okay. And to use it, you'll notice that in this program here, there's no main. Okay. And there's no main in the H either. So we need another file, which would be our program. Okay. So maybe this is my program.c, which would be your lab work or whatever. And then in here, you go hash include useful func.h. And then in here, you'd have your int main. You can also include your standard IO as well. Hash include standard io.h. Okay. And then inside of here, you could do int value is upper case, and maybe put the letter A in there to check if it's uppercase. Okay, so here, this is how we can write libraries of functions so that we can use them in our program. And this means that I can now go ahead and go over here and write another program that includes this. So you remember weeks back we did useful array functions. You could turn that into your own header file and C file combination such that you can use it here. Now, when you compile, you need to compile both of these, as you'll see in the lab this week. But that's the general principle of what we're doing this week. So the way we usually do it is we do a pair, so useful func.h, useful func.c, array functions.h, array functions.c, if you want functions. If you just want macros, then you only need the .h. If you just want variables, same thing. There are some other keywords, but I'm not going to worry about that right now. So there's things like extern, but let's just keep it simple for now. Okay. So in the lab, you're going to use a set of these that I give you. And then in the second part of the lab, you're going to create both of these for yourself. Okay, does that make sense? So if that makes sense, just say so in the chat, and then we'll continue on, or we can go over it again, or whatever. This part isn't huge if you don't understand all the complexities of it. It's actually quite a big topic, and we don't go into it that deeply in this subject. But as long as you get the idea that we can break up the code into smaller chunks. All right, so if you're all up to the same point, just say something in the chat or put a little emoji, and then we can continue. I'm just wondering if there was anything else in week 10 lab we haven't covered. Cool, so the only thing that I might go and grab is this. No, not like that. All right, so I might just give you, let's see if I can do this. Let's do it on the desktop. All right, so I'll just give you a preview of the file because this is where most people had a lot of trouble. So that's the, I just need to get rid of students code. Close all of this. Oops, did not mean to do that. Cool. All right, move to other view. Move to other view. Oh, and I still got to fix this. All right, so if you have a look here, this is the code that you're going to use this week. And why I'm giving this to you is the fact that what you're going to find quite often when you are actually doing a lot of code in the future, it is impossible for one person to know everything. Okay, and that's why there's a lot of APIs and open source code available because there's lots of complex code that it's either pointless for you to create because someone else created it, or it may be that you're not an expert in that area, but you still should be able to use that code, but not write it yourself. And that's the whole purpose of this lab. So we've got some hairy code in here, but you will be able to play with it quite easily by the documentation. So the code on the left is our header file. We've got a .h. I don't know if you can see it. It's a little bit small, but that's our header file. And all it has here is function prototypes. That's it. And a couple of macros. And it also has some includes. Okay. So you'll notice that there's no actual code in here. It's just function prototypes and preprocessor directives. You'll notice that there's function descriptions, okay? And these are quite detailed because if they're not, then you would have no clue how to use this. And this is why your documentation is extremely important here, because if someone else can't use it, then it makes it very difficult. Then if we look at the C file, it's got the same thing, but it's got the code in it, okay? And you'll notice that it actually doesn't matter what the code is. All you really need to know is this. And this is why there's important documentation, because some of this code might be a little bit difficult, but if you can just read this, it's fine, because you should be able to understand the documentation, but not all of the code, okay? And so if you have a read, you can see that you need the address of the pointer. You know how to get an address of the pointer. It says cast the argument as a void quadruple star. You know how to typecast. It says the size of the X dimension passes an unsigned car. You know what an unsigned car is. You know what your dimension is. So this is about matrices. And then the size, type size in bytes, pass as size of type of matrix. You've seen size of already. And then you've got sets how to initialize the matrix using the following macros. So one of your parameters is just the macro. And you have access to all of those macros. Remember, you've included this so you can use these in your program. So you can use these in your call. So by reading this, you know how to use this without having to go into the code and go, oh, what's this? Why is this here? Why is this here? What's this? Okay, you don't need to know that. Rather, you can access it via this interface. Does that make sense? Okay, so this will help you with this week's lab and should get that pretty good. Now let's go. So if it's all good, just put something in the chat. It can be an emoji, it can be something else, it can be whatever you like. I just need to know you're here and we can continue. All right. So let's wait for a couple more and then we'll continue. Assignments. Okay, so there's not much else to talk about in regards to the next lab. It's all stuff you've covered before. It has two-dimensional arrays, but you don't have to create them yourself. So it's nothing new other than the header files. Okay. So just quickly on assignment 3, I haven't got too much to add unless someone's got a question. So last week I went over the main functions. So I went over main, load, free, and save image. We also had a quick look at save copy image with string cat and those functions. And what I basically said is that you should try and get those working first, because if they work, the rest of the assignment's fairly easy because you can visually check with your eyes it's working or it's not working. If it's not working and you come to the lab this week, I can identify what the problem is fairly quickly. So just let me know and we can have a look at it. If you wait till Saturday before the assignment's due, there'll be no one to help you and it's impossible to do the rest of the stuff. And we will be marking based on the output. So if the first part doesn't work and you can't produce an image, you can't produce any of this stuff, no matter how good the code is. You need to make sure that these work. Okay. So really, really try at doing this. From there, you've got the change luminosity. That one is basically the steps are given for you. It tells you exactly how to do it. I haven't seen any students struggle with that. It should be fairly easy. The next 4 are very similar. Okay. They involve removing pixels. Once again, I haven't seen anyone have too many troubles. The inverting the pixels, okay, you need to think about basically, so inversion is basically toggling. We looked at toggling a couple of weeks ago, This isn't toggling a single bit though, okay? It's toggling the entire byte. So the way you do it is going to be a little bit different. Experiment and see what you can get. Basically what you want with the invert, so I'll show you, where's my thing? Okay, and you can test this yourself either by just trial and error, or you can think about it on a piece of paper. But I'll do it in red because we've got red. So let's say your red picks, would help. Why is this broken? Okay, my pen is broken. It's going to drive me nuts. I need to. Really annoying. So let's say the red byte, okay, is 0, 1, 0, 1, 1, 1, 1, 0. All you want to do is find some function that converts it to 1, 0, 1, 0, 0, 0, 0, 1. Okay, so you need to think about how to do it. Now, I've given the clue that you need XOR, okay, and that's the easiest way to do it. But you need to work out what to XOR it with such that you get an inversion, okay? So play around with it, experiment. There's quite a few little small questions on bitwise operators on the exam. So it's good to just have a play and see what happens when you try different things. And then you'll finally get it. And this is only one line per color, so it's not very long. Okay. Then what have we got? Then, now I've lost it again. Then we have Quantize. So this is also a bitwise operation, and this one can be done very short or it can be done very long. Preferably the short answer shows that you understand bitwise operations. And this one I definitely recommend. Don't just go and code it. The XOR one with the inversion, yes, you can play around with it and you'll probably finally get it. This one, if you play around with it, you probably won't get it. You really need to sit down and think about it. Okay. This one basically removes the lower bits by setting them to 0. Okay. And depending on what the user enters. So if the user enters 1, then it should change the lowest bit to 1. If they enter 2, then both the bottom 2 should be zeros as well. Okay, so you need to think of how to do this. This does involve shifting. It doesn't have to, but it's a good idea. But try and come up with a good solution rather than a big if, else if, else if, else if, else if, else if. That's not a very nice and elegant solution. There is an elegant solution to this, okay, that you can do it in one line. Okay, one line per color is what I mean. Okay. All right. The flip the horizontal pixels. So first thing I'm going to do is, just because I think this is important. Okay. There we go. That's a nice picture. That's a horrible picture, actually. There we go. That one's a good one. All right. So I will just get you this so that it's clear. And I won't draw it myself. I'll steal it. No, I won't. I won't steal it. All right, whatever. Copy image. Why is Google Images full of stuff that doesn't want to get across? Everything is I'll stuff it. I'll draw it then. All right, so if I've got some image, okay, let's say it's an arrow pointing this way. It flipped horizontally, okay, is going to be like this. Okay, so that's flipped horizontally. When we're flipping horizontally, not vertically. Okay, so just be aware of that. Okay, now with the flip, we actually did sort of a similar thing in the bubble sort algorithm where we swapped bits, because basically all you're doing here, okay, is for every row, you want to take that, and swap it. Take that, and swap it. That's all you want to do. Now, the first thing you should notice is number of swaps is half, okay, is half the width, okay? That's definitely something you should notice. In terms of swapping, remember that you need to store the values somewhere temporarily, then swap it, and then overwrite the other one. Okay, so basically I'll do an example of a swap. It is in lab where we did the bubble sort, but I'll do an example. So let's say we've got A, B, C, and D. To swap the last two, the first thing I do is I make a copy of A and put it somewhere. Then I will go to D and copy over this. Okay, and I need to make sure that I made a copy because at the moment I've lost that A. And then lastly, I'll write that A here. Okay, and that's how we do a copy. And it's in the lab where we do bubble sort, because that's what we're doing. We're moving things around in an array to put them in order. We're here, we're just flipping them to change the order. Okay, so basically, if you have a think about this, you've got a for loop that's doing each of the rows, and then you've got a for loop that's going to go around a particular number of times. And inside of that, you're going to be doing something. Make sense? It's making sense? Say something in the chat, and then we'll continue. And I just want to talk about one thing about the last part, just to help you out, if you are brave enough, because yeah, we'll talk about it. Cool. All right, where's my turtle? Okay, so generally for scientific computing and engineering, usually you try and avoid break because it reduces program flow and testability, and it adds an element of danger into your code, which can always be avoided. Break can always be avoided with a flag, and hence a flag is traceable, testable, and accountable. Okay, so if you need to have code that's going to actually be used in a scientific way, you try and avoid break. If it's going to be used in a medical device, you prefer some traceability so you can test it rather than your code just jumping to another point. If you've got a flag there, you can at least test that flag over and over 100,000 times and go, this works 100,000 times, you can use it as a medical device. So generally, you try and avoid break, and if you can't do it without break, then it shows that you don't have very good problem solving skills, because it means that you're just relying on the fact that you can just jump out of somewhere and reduce the testability. So if you want to use break, you're welcome to. We are not taking marks off for it, but for the assignments and stuff like that, we are taking notes of the students that get 100 and then the students that get 100 plus. Okay, especially for the engineering students and stuff like that that want to get into these kind of fields. Okay. And some of the master's students as well. All right, so you can if you want. It's the same with case statements. We try and avoid them because they actually compile differently, and it's usually not recommended. Cambridge University, their art of scientific computing basically says you're not allowed to use, well, it doesn't say not allowed, it says it's highly discouraged, and so I follow that advice. So there's stuff that will work, but just because it will work doesn't mean it's good. Okay. And there's, as you probably know, there's millions of coders in the world, and there's a lot of amateurs that can produce the same thing. They can flip the horizontal pixels, they can do all this stuff. But it depends on what level you want to work at. So it's up to you. If you just want an output, then that's fine. All right, so assignment 3, we then get to this crop image, and we get to this reallocate pixels. Now, I'm not expecting, what's going on with my chat? Save. I'm trying to remember. Quantized level of 0. No, quantized level of 0 should do nothing to the image. So quantization level of 1 would clear bit 0. Quantization level of 2 would clear bit 0 and 1. Okay, but quantization level of 0 should do nothing. Okay? It should just leave it alone. Okay. Now I've lost what I was doing. Reallocate. All right. So if you are going to try this one, be very careful. No, there shouldn't be a level 8. Did I put level 8 there? So yeah, no, it says it on the assignment sheet. Yeah, look, 0 to 7. Oh, you mean 8 is in clear the whole thing? Okay, so no, there's no level 8 because that would be pointless. Because that means that all the bits are 0. So it's just every single bit is going to be 0. That's not quantization anymore. That just means your whole image is gone. So definitely a level 8 would be pointless. You can try it, but you're just going to get a blank image at that point. So you're welcome to try it, but it should just clear the whole image because you've cleared every single bit to 0. Does that make sense? So a level 8 wouldn't really, yeah. You can try it though. It's very easy to try. It's not going to do much. All right. So your crop image, a lot of you will probably get this to work, but you won't actually get the memory freed correctly. Okay. And that's fine if you want to try it. You need to consider a couple of things. You also need to update the struct with the width, height, and file size. So that's one thing that a lot of students will forget. But then when it comes to here, there's actually 4 operations that need to be done. The order is a little bit complex, and how you do it is a little bit complex. But basically, I've listed these here, and you need to work it out. It'll look like it's working depending on which order you do it, regardless, or it will segfault. If it's segfaulting, try and understand it and try and fix it. If it keeps segfaulting, just comment it out and leave it out, because it means that you don't understand it, and that's fine. Okay, this is meant to be a more challenging question. But you've got 4 operations. You've got a free, you've got a bunch of frees in a for loop, you've got a bunch of reallocs in a for loop, and you've also got a malloc. Okay, that malloc is actually important, and it's important that you don't use your original row pointers, rather you make another set. And I'll just show you that right now. And this is a common mistake when people use realloc, and the compiler doesn't tell you this, but it is very important. So let me go here. So basically, this is what you shouldn't do. So if you've got some pointer, okay, and you wanted to, let's say it points at some dynamic memory, okay, blah, blah, blah. And we want to realloc that, okay. This is what you should never do, okay. So some size, let's say 2, okay, let's say they're cast or something. This is bad, okay. You should never realloc and return to the same pointer in the one step, because if the realloc fails, you've lost your pointer, and so you've lost all your data, reallocated or not reallocated. You've lost it because you've overwritten it here with null. Okay, so you should always have another pointer here. Okay, and so you can probably see why we need a malloc in this, because we don't want to return this pointer back to where it came from. We want to reallocate it back to here. Okay, so that'll give you a little bit of a clue. I don't want to give too much away, but that might help you with that. Okay, and that's the purpose of the malloc. And yeah, you shouldn't return the pointer to the same place, because yeah, that if it fails, it's really, really bad. So that's only if you want to try that. You can get still like 95, 96 without this. But just for those that want to try something a little bit more difficult, there is this for you. Okay. All right. Is there any questions? If that made sense, let me know, or put an animal in the chat, and then we can go over some other stuff. I don't think there's much more on the assignment, really. I think I've covered everything in depth in the last session, and from what I saw, most people that I saw last week had done it and it worked, or those that had it partially working, at least I could help them fix it. So just put something in the chat to say you're up to here and it's all good. What we might do is have a little bit of a break for 5 minutes, and then we can come back with So when we come back, I'll talk about the exam and exam practice and all that stuff. And then any questions? Else we can go through some quiz questions, or we can go through some exam questions, or something else. So just put your numbers. If you've got something you want to suggest, we can. Otherwise, I might just go over some random questions randomly. So let's just have a quick break. Drink. Let's say 5-minute break. It doesn't actually matter. fix this pen. All right, I'll be back in 5 minutes. All right, if you're here, so what I was going to say is basically for exam practice, Rick is planning on running a practice exam, which I highly recommend you go to. That'll kind of give you a good indication of where you're at. And then what I plan to do, and I've done in the previous years, is usually run a live stream for about a day, probably on the weekend before your exam, going over everything in the subject right from the start. This depends on obviously participation. Last 2 years were pretty good in terms of participation, so I was able to do it for the whole day. If no one shows up, then I'll just end it straight away. This is something I'm doing in my own time, not part of what I'm meant to be doing. So this is up to you if you want to get involved with this. I can tell you that it really, really helped the students with their exam in the previous years. And most people there that did take the whole day to study with me did all get very high marks in the exam. So that's probably going to happen as long as everyone's still keen and respectful and want to do something like that, then we can do that still. So I guess right now, what I want to ask is there any questions? Is there any topics that we want to go over right now? Or do we want to just go through some exam questions? Or is there something else that we need to discuss that I've forgotten about? Or we can have a look at some solutions for labs or whatever. This is kind of your time to ask whatever questions you like. Where'd my LMS go? Can you hear me as well? That's the other thing. I hope you can hear me. I hope you're all still here. So if you're still here, just let me know as well. So any questions, you're welcome to ask. There's no bad questions, no wrong questions. So let me know what you want to do for the next hour, because we can kind of do anything. Actually, guys, that's actually an excellent question. So someone asked an excellent question on the forum, which I'll answer now because that makes it easy. So I'll answer this question and then I'll answer your question. That's an excellent question as well. All right, now, I left my. Okay. Give me 2 seconds. I think I left my. All right. So someone asked in the student questions a really good question, and that's the difference between string length and size of. So what I will do is I'm going to create a string. Actually, I'll create a car. I'll call this str, and I'll make it, let's say 10 long. Okay. And I've got to remember that. It's not working. And then what is going on? And then we'll make an int array, which is also 10 long. Okay. We then do a scanf, and just imagine we ask the user for a value. I'm not really worried about that for a string. It's gonna be interesting. Let's do a for loop. For I 0, I less than, let's say 5. Yeah, let's say 5. I plus plus. And then we go scan f %d and we'll do the address of I. Okay, so let's say we've got the inputs hello, 1, 2, 3, 4, 5. Now, this is going to be important in understanding the difference between these. I'll put both of these two different types of stuff that's happening here. So we get our string, and our string looks something like this. We've got a H, an E, an L, an L, an O, a null terminator, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we've got uninitialized values after it. Okay. Now, our int, on the other hand, is a little bit different. So here we have 1, but that 1 is over 4 bytes. We have 2, and that's also over 4 bytes. We have 3, which is also over 4 bytes. We have 4, which is over 4 bytes. We have 5, which is over 4 bytes. And then we stopped our loop there. So we have 1, 2, 3, 4, 5. We have 5 uninitialized points. 1, 2, 1, 2, 1, 2, 1, 2. All right. Now, if we did size of, so let's do it in a print because it's kind of silly to do it here. Sorry, my pen seems to be broken. So we'll do a printf %d. And if I did a size of R, what I expect to get is 40. Okay. The reason that I get 40 is because there is 40 bytes here. Okay. It's an array of ints. Okay. There's 10 of them times 4 bytes gives me 40. Okay. If I change that now and I make this size of str, I'm expecting to get 10 because there is 10 cars and each car is 1 byte. However, if I write here instead strlen, then I will get 5. Okay, so it counts the number of characters up to the null terminator, not including it. Okay, that's the difference between string length and size of. Now we can't put R here, it's the wrong type, and we'll just get undefined behavior, and you'll get a nice ugly warning. But that's the difference between them. Does that make sense? Okay. So size of is just counting the number of bytes, where string length counts the number of characters up to the null terminator. All right. Now, let's double check there's no other questions on the live stream, and then I'll get to your question about testing. Ah. I'll need to double check that. All right. So testing. So we cover two types of testing in this subject. We don't really do much with it. So we can have a look at the testing hierarchy to start off with, and then we can have a look at black box and white box. So the highest level, the lowest level of testing in our hierarchy is usually going to be a unit test. Following that is going to be an integration test, and then a functional test. There's other types of tests, but they're the ones we focus on in this subject. So basically, a unit test is a small isolated block we can test by itself. So in C, usually that's a function. Okay, so for example, we might do a unit test on the bubble sort algorithm. But our unit test could also just be the swap. Okay, if we can isolate the swap in there, we could do that. So it's usually just a very small block of code, and we just want to test that by itself. An integration test checks that those things work together. So for example, our main passing our array into our sort, and it comes back correctly, might be an integration test. We've got a bunch of things working together here. And then a functional test actually tests the functionality. So this might be the user enters a value and they get their money out at the end, or they get their product or whatever. Okay, so these are the kind of different hierarchies in our program. Now, there's two main types of tests within these. So we can use black box or white box testing for any of these. Why is it going so slow? All right. So basically, a black box test looks like this. Data, output, known output, compare. Okay, so that'll be some file or some system like that. So basically what this is doing is the code here is not known. Okay, so I tell you we're going to do, let's say, a Fourier transform. Okay, and you don't know how the math works or anything like that, but you know the right answer and you know the wrong answer. And basically, you just feed some data in, and then you compare if the right answer comes out or the wrong answer doesn't. So this is completely data-driven. Okay, the logic of the code is hidden. Okay, so you can't see any of the logic. And basically, you're doing it against some known output or some specification. Okay, and that's kind of like the testing we did in the last week's lab. Okay, we basically fed it some data from a file, and then we compared, was it right or was it wrong? So it was purely black box testing. On the other hand, we have white box testing. Now, white box testing is a lot more difficult, and I'm not going to go into all the depths, but let's say you've got some ands and ors and stuff like that in your program, where things can branch off and go in different directions, maybe branch and branch. Okay, so here you're actually looking at the logic of the program. Okay, so imagine you've got a flow diagram inside of your program. Basically, you want to see, does this here actually branch off at the correct location? Is it moving? Is the logic working correctly for each one of these if statements or else ifs or for loops, etc.? Is it going to the right location? So you actually need to know what's in the code to see if it's moving through the code correctly. Okay, so this is our logic, okay, and this is why I talked about logic when we talked about flow diagrams, because that's what we're testing here. We're testing the logic here. It's path oriented, okay? So it's about following different paths throughout our program, right? So that might be the correct path. Or it was meant to do this path, okay? So we can see, did it follow the correct path? Did it not follow the correct path, etc. Okay. Does that make sense? Okay, and that's, if you can kind of explain that in an exam, that'd be a good enough answer. You don't need to go into too much depth. You don't need to go into formal specifications of how we do it, just as long as you know the difference between them. So if that makes sense, let me know in the chat. And we'll keep going. Some more questions. I'm going to set up the lab as well. So if that's making sense, let me know in the chat. Nope. Okay, what doesn't make sense? You said nope, so can you elaborate? Elaborate? What doesn't make sense? S. I'm not sure what S is. Oh, no questions. Okay. All good. I thought you meant you understand. That's all good. That makes sense. All right. So, is there another topic that you want to recover? Have a look at anything. Happy cover anything. We can go over pointers. We can go over box and pointer. We can go over flow diagrams. We can go over hexadecimal. We can go over if statements. We can go over for loops, bitwise. We can go over anything. Printf. I really don't mind. We want to go right back to the start. This help session is a bit more open for you to decide what you want to cover. We'll go over some more exam-y stuff later. Anything from the assignment 3, from the early parts that didn't quite make sense, or you want to understand it in more depth, so you can write better comments. There's plenty we can talk about, but I need you to tell me, because if I just pick something at random, it's not going to be great. So what would we like to cover? I'll give you a minute. What am I doing? All right, I'll give you 5 minutes to think about it. No, don't open that software. Software will take 10 hours to open. So I'll give you 5 minutes to put questions, topics, quiz questions, statements, etc. in the chat, and then I'll go through them all. Okay? So I'll give you 5 minutes to do that, and then I'll have a look at this. That's an excellent question as well. All right, so we'll do that one. We'll give you 5 minutes to write a bunch of stuff. Just go through the notes and see which one you'd like a little bit more information on. So you can go through your quiz questions. I know there's quiz questions. Some of them are horrible, and we'll probably find some. everyone knows everything. All right, so let's talk about pointer arithmetic and the difference between pointer arithmetic and just using square brackets. And then, so I might do a print scan. Yeah, we'll do a print first because print is fairly standard. All right, so I'm just going to do this with standard arrays. I'm not going to bother malloc anything because I want to be able to use initialization. So I'm going to create an array and let's make it not too big. Let's go 6. And it has the values 1, 2, 3, 4, 5, and 6. And then what I want to do from there is create an iteration variable, single iteration, then a for loop, I less than 6, plus, and then I want to go in here and do a printf. And then I'm going to do %d. All right, so I'll leave that part blank. That's fine, that part's fine, that part's fine. All right, and then we'll copy and paste this. Put that there. All right, so we'll do this 2 ways. Kind of in the way, myself out of the way. Let's see that semicolon. Put a line through there as well. All right, so we've got 2 bits of code. In this one here, I'm going to do I, and in this one here, I'm going to do int star. Let's say, sorry, I've got to fix this. I'll do r pos takes on r. And then here, I'm just going to do r++. Okay, so first things first is wherever you see this, that can always be replaced with star r plus I. Okay, and they are both as fast as each other. They're not going to be any different in terms of speed if you write it like this or write it like this. Generally, it's better to write it with square brackets because it's easier to read. So if you're writing it like this, it doesn't do anything. Okay, it's nothing special. And I forgot the dereference here. This here, on the other hand, is a little bit faster. Now, I'll show you why in this little demonstration. So what I might do is I might just write this. Actually, I'll write it as that form because it'll make a bit more sense of why it's. Actually, I'll do both. Plus I. So when you see this, that's what it's doing. This here is a little bit different. All right, so where's my eraser? Let's get rid of this. So this is an excellent question because it's good to understand pointer arithmetic. We're doing very basic pointer arithmetic, just going through something, but you can do more advanced pointer arithmetic, like jumping to particular places in memory or skipping over large chunks of memory. But this is just a nice little introduction to it. So here we've got an array which has 1, 2, 3, 4, 5, and 6 in it. We've got R, which points to the start. Okay, and I'll copy and paste that because I need that again. We'll put that over here. Okay. Now, the difference here is that I have another pointer pointing to this location. Now, if we break this down into what's happening right here, we have r plus I, so plus 0, okay, dereferenced, which grabs a 1. Ri does the exact same thing. Okay? So you can see that that plus is one operation, and then we've got this here. Over here, however, we grab the value first, then we increment the pointer. So we actually grab the value. So the value is going to be the address of this, okay, address of, let's say, how do I write this so it's nice? I'll just give them values. Actually, I won't. I'll just, what's the cleanest way to do this? Because I'm using the plus plus in one line, it's a little bit, so basically it does that. Okay, that's probably the easiest way to show it. Then it does the plus plus, it's post increment, so that gets put over here. Okay, and then we just dereference, so we get the 1. Okay. In this one, in the next one, we start from here, and now we have to add 1. So we're going from here to here, and then dereferencing it. Okay. We're here, what we're doing is our pointer's now here, so we go and grab that. Okay, so we go and grab that pointer, and then we increment our pointer using the plus plus. Okay. And then we dereference and we get the 2. Now, from this, you can clearly see that there's no addition. There is an increment, which is a unary operator, which is faster because it's not between two things compared to a plus. Okay, plus is actually slower. Plus, we know where we're up to in our array. Okay, here we actually don't. We have to use the I to work that out. We don't need to keep coming back and forward, back and forward, back and forward. We just keep moving across. And if you're doing like lots and lots of multiplication or something like that, you just want to nicely move across rather than moving backwards and forwards over and over again. And this is why this is faster. Now, if this is a scanf, on the other hand, then we get a couple of more advantages. So let's go and have a look at the scanf. So scanf, layer I'm on. Scanf, you don't need this. We can make this a scanf. Make this a scanf. And now it's actually better to get rid of this and use r plus I. I'll explain why in a second. Let's go here. So scanf, on the other hand, when we do address of I, it's actually faster to do r plus I. Okay, the reason for that is because remember, ri is r plus I dereferenced. If I put an ampersand in front, they cancel. Okay, so it's actually quicker to write this with a scanf because it's directly grabbing the address. So here we can write r plus I, and that is slightly better. Okay, this is getting to the low-level optimization. It really doesn't matter unless you're interested in these things. Here, however, we have one unary operator. Here we have one binary operator. Binary operator is going to be slower because it has to pass through the ALU, where here it's actually faster because it's one unary operator. Okay, so that's why we do this. Cool. how clear it was, but basically, yeah, it's about optimizing your operators. But we can do some really, really cool stuff with that. Okay, so have we got any other topics, questions, things that were a little bit hairy? We can do box and pointer, we can do for loops, we can do if statements, we can do nested, while loops, whatever. Where'd my big finger? Where were we? Here. Topics, quiz questions, statements, quiz questions, things you got wrong, things you got right, things you don't understand, something from the exam practices. Let's have a look at the exam practices. What have we got on here? All types of loops. Sure, we can go through all the types of loops. All right. So where should we? Let's find a nice empty space. Beautiful. All right. So we can go through all the three types of loops. So in C specifically, other languages have more loops, but C has three kinds of loops. Okay, and these are basically just repetition. Okay, so this is when you want to do something over and over again. The thing with loops is if you know how many times it loops. So for example, I said to you, I want to print hello 3 times. We could put this in a loop that loops 3 times, or we could just copy and paste it 3 times. I don't even know what happened there. Why is that layers shouldn't be stuck to that one? Okay, so we could copy and paste it 3 times. All right. And that's what a loop is doing. It's just doing the same code over and over again. Okay, with some helpful things in it. So if we know how many times it's going to loop, so it's a numeric value, we could always replace our loop with just 3 lines, for example. But that's not very good, because what if I tell you it needs to loop 10,000 times? What if I said 100,000 times? Or even the case where I say, I don't know how many times. Now, that's difficult, okay? What if I wanted to loop on a non-numeric value? So I wanted to continue until the user hit Q, or no, or until the value was greater than 100. Now it's not as simple as being able to copy and paste, and this is why we require loops. So let's go have a look at our loops and why we need them. All right. So our 3 types of loops are our do while, our while, and our for loop. Now, our do while and while are usually used for some kind of logic problem. Okay, generally they are used for logic, where for loops are generally used for iteration or counting. Okay, so a do while or a while, if you've got some kind of logic like continue until the door closes, continue while the door is open, continue until the user quits, continue while the user enters a valid value. This is usually where we need this, where if I say print all the values out in an array, then you need a for. If I say print the values 1 to 10 counting up by 2, that's a counting task. It's a for loop in most cases. Now, there is one thing to note. You can do any looping task with any of these loops, but choosing the most appropriate one, that's where you need to use your knowledge of what iteration is and logic is to know which one to use. Now, the other question is, we've got do while and while. Well, they both do logic, so why use one or the other? So a do while does things 1 to n times, or a while does something 0 to n times. So, for example, a do while is usually used in menu systems because it must show it at least once before the user can quit. Where a while loop may be used where the logic may already be false before you enter the loop. Okay, so for example, loop until the door closes, but the door's already closed, so you don't want to loop at all. Okay, so it depends on what your state of logic is and what you want your logic to do. Do you want to show it at least once, or do you want to be able to quit the loop straight away from the start without even looping once? The syntax for a do while loop is important because it has this while here and then it has a semicolon. The while loop is like this, and the for loop is like this. So we'll create a variable. Actually, we'll do it a different way. We'll do it just as syntax. So the syntax, I'm just going to put as A, B, C, where A is the initialization, B is the condition, and C is the update. Oh, I forgot that. All right, so your stopping condition, okay, goes here, here, or here, okay, and they all three of those work exactly the same. So continue while A is not equal to B. Continue while Z is greater than 100. For I is less than 10. The special additions the for loop has is the initialization. So you would have seen this where we can set the starting value of some iterator. For a for loop, a single for loop, the iterator is always called I or a meaningful name. For two-dimensional for loops, so if you have a for loop inside of a for loop, then you can use J as an iterator or give it another meaningful name. The other addition we have in a for loop is this guy here, which is our update, which will allow us to update a particular value, usually the iterator. Okay, does that make sense in terms of loops, or do you need an example? So let me know if that makes sense, then I'll move on to provide an example. Okay. Of which one? So it's going to be all of them. It might take a while, and I can just refer you to videos. But if there's a specific one, spend some time. But all three is probably going to take a bit too much time. But do well. Okay. So, for example, let's say I want to do a menu system. So let's say I want to ask the user if they want to quit or add two numbers. Okay. And I want to keep asking them that until they quit. Okay. So I'm going to create a variable up here. And I'm going to call it, I'll call it car choice. Okay. And then inside of this, I'm going to have a do while. Okay. My logic and thinking here is that the user is going to be asked a question and they continue while their choice is not going to be quit. Okay. So we'll define that now. So let's say quit is going to be the letter Q, which makes sense. So do while choice not equal to Q. Do while the user's input not equal to quit. Okay, so do this while, and just read it as natural English. And that's the easiest way. Do this thing while user does not want to quit. Okay. And then in here, we can just do a printf, enter. Oh, so let's make it simpler than that. A is add, Q is quit. Okay, so we're just printing that to the screen, to the user, and then do a scanf. I'm going to put a space there because we're doing %C. And then I'll do ampersand choice. And then do is just move down a little bit. No, I don't want that. And then I might just do an if choice equals A. Then let's say it just prints out values added %D 1 plus 1. It just said add. It didn't say that the user was going to enter the values. Okay. So that's an example of a do while loop. So it comes in, it gives the option. Okay. It needs to do this at least once. Okay. Because the user can't quit before they're given the option. So it needs to happen at least once. Then I get the option from the user. If it's add, then it says it's add. A is not equal to Q, so it'll come back up again. If it's a Q, then it will quit. Does that make sense? Or do we need a little bit more clarification in any of those points? And if you want to see all of them, where are they? Yeah, so on week 5 tab on LMS, there's a longer video. Use of malloc and calling a function. All right, I need to answer the first question before that. Okay, I'm a bit confused in deriving the struct from header place using inside the functions main, in particular why we use 2 dots while deriving them. Can you clarify what you mean? I'm not quite sure. Your question doesn't make exact sense. So can you just clarify or give an example of what you mean? Are you talking about structs in a header that you've written? Or do you mean a .h file with structs? I'm a little confused. So you're talking about headers and structs. I don't know if that was in the lectures, but we can talk about it if you are using it. Usual struct file. There's no such thing as a struct file. There's header files and C files. We don't have, so you can have a struct in a header file as a definition. So a .h, you can create your definition of your struct, or you can have your definition at the top of main, or above main, sorry, or you can have it inside of a function, but we're not really going to do that. So so do you mean in main, or do you mean in an actual separate file? Well, can you give an example? Because I'm a little confused at what you're asking. The use of malloc, that's probably going to take an hour or two to cover. So I'm going to leave malloc out for now. I recommend you go and there's about 2 hours worth of videos on week 8 regarding malloc. We can do a whole thing on malloc a little bit later, but I don't think we've got enough time right now, considering I've been going for about 2 hours to cover malloc, because that'll probably take a bit too long. I want to hear this other person's question. Calling a function we can go over, that's easy. I mean, usually we define struct something. Yes. Do you want an example of a struct? Or do you want to understand the dots? I don't know what you mean by 2 dots, though. There's only ever 1 dot. Wait, let me have a look at your question. Deriving I don't know what you're deriving. Inside the function's main, in particular, why we use 2 dots while deriving them. Okay, so firstly, okay, cool. All right, so basically, you're asking not about deriving. All right, so you understand this concept. Okay, that's the most important thing. If you understand that, then you understand structs, in my opinion. Okay, do you understand what is written here? I hope so. So this is a variable, okay? Its type is an int, its identifier is A, and it has 2 primary roles, storage and retrieval. And that's what it can do. Now, structs are basically the same, except for one thing. They can have multiple data types inside them. And we can define which data types they are. So we can write something like this in our main. So struct student has, I'm not going to do I can do a string. Actually, I won't do a string because I'll keep it simple. So we've got a student and they've got a ID. They've got a year level. And let's say they've got a grade. Okay, a letter grade. Okay. Now, this here is really important. This up here is not a struct. Okay. It's not actually a struct. It's the definition of not a struct, but of struct. the struct student. Okay, that's the first important thing to understand. So this here is like our template. This is what our data type's going to look like. Okay, it's like saying our variable is int. That makes no sense. Okay, this is not the actual struct that either does the storage or retrieval. It's just the definition of it. Okay, we've defined it. Okay, there's no deriving, it's defining. Okay, so we've defined what we want this object to look like, or this thing, or this structure to look like. So we've said that a student has these properties. It has an ID, a year level, and a grade. Okay, if you were doing it maybe on a frog, it might have the color of its skin, the color of its eyes, and how high it hops. So we're defining what this structure looks like at this stage. Okay, it's not the actual struct. Okay, it's the definition of our struct student. Now you'll notice that this is uppercase, and that will help you with that definition. Now, we need to declare this. And as you said before, you understand this concept. As I said here, that's the definition of our data type. So this is really, 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 really important that you understand. That there is the type. This here is a type. It's a definition of the type. So when we declare it, we write struct student and then the name. Okay, so it might be student A. Okay, that there is declaration. Now that part here is the type. Now I know that it has a space in it, and it gets a bit confusing, and understandably, okay, it's pretty confusing that it has a space in it. Okay, so it's not like it's stupid to think, oh dear, it has a space in it. Yeah, it's a bit strange. It's very strange that it has a space in it, but you need to get used to that. Okay, but that's the type. Okay, so when you see this word, basically what I recommend most people do, especially if you're in an exam or something, is go, could I write int there? And it would work the same. Okay, now there's no such type. Okay? And this is also important. There's no such type called struct, and there's no such type called student. Okay, that's the other thing that's key here. The type is struct space student, all as one big thing. But then you've got the identifier. Now, from here, what we want to do is be able to store and retrieve. That's the basic properties of a variable. It can do two things. It can store and retrieve, and that's about it. So this data type is not like our floats and our ints and our cars. Rather, it has members. And these, going off the page, I'm going all over the place. These three things here are called members. And there could be lots of them. There could be a couple of them. It depends on the situation. So for example, if you're explaining a more complex thing, so maybe it's a network connection, or it might be describing a book or a journal, or it could be anything. It could be something very abstract. It could be something very serious. Obviously, a student, we could fill that up to 100 different variables, members, sorry. Okay. Now, to access those members, we use the dot operator. So student A, okay, this student A is of type struct student, which has these three members. Okay. And so we can access each of those things, either for storage or retrieval. Now we remember that storage, okay, left-hand side, retrieval, right-hand side. So let's do this. So I want to be able to set the ID of the student to, let's say, 17. So I'm going to write student A dot ID is 17. This here, this student now has an ID of 17. Student A by itself can't be 17, okay? Because its data type is actually of a struct, meaning that it must have members, okay? So here, I'm going to look at retrieval now. So I'm going to have another variable called, let's just call it B. That's not a very interesting variable. And I'm going to retrieve that ID. So I just write dot ID. And this is basically the use of dot. It allows us to get or retrieve or store things in the individual members. Does that make sense? All right, Carl. We're losing people. Stage into function calls. Cool. So I didn't do a video on struct, did I? I do a video on struct. So I don't know if you remember or if you were at my lab, I went through basically every single way you can use a struct. So from here, we can do more crazy things. I might leave that there for now. But if we have time next week's help session or before the exam, I'll go through that again. It's a good hour talk of where we'll talk about arrays with these dots, pointers with these dots, every single different possible thing. And we did it in my labs. So if you were there, I hope you saw that, so that helps. Otherwise, we will go over it. I'll go over it with you, because I think it's, once you understand it, in your brain, all you need to think when you see structs is this, okay? Even with pointers and stuff, okay? So we can come back to that a little bit later. Cool. If you were there, hopefully that makes a bit more sense. It's probably a while ago and it's probably a lot to take in. But we'll go over it again, okay? Because I really want you to understand the pointers with structs for the assignment 3. Let me see how we go for time. I kind of want to answer. Well, is the person that wants to know about function calls still here? If they're not here, then we'll go over it. We'll go over some more struct stuff because it'll help you with the assignment. What I'll do is I need to have 2 minutes. Oh, you're still here. Beautiful. All right. Give me 2 minutes and then we'll go over function calls. And then if I have a bit more time, we'll go over struct pointers because that'll help you with your assignment for the other person. I might need a new board. Oh no, I don't want that software. Oh, that would actually be good. All right. All right. So I'm just gonna have a quick 2-minute break, and then we'll do function calls. Shouldn't take very long. Function calls, and if we have time, we'll have a look at struct pointers. All right, give me 2 minutes. All right. So let's keep going. So function calls. So, all right, so a couple of questions. I'll get back to that in a sec. Let's just quickly go over function calls. And so, basically, since week 1, we've been doing function calls. So, take, for example, printf. Okay. This here is a function call. Okay. It's not the definition of function. It's not a prototype of a function. It's actually calling the function. Okay. And that's what differentiates it from our descriptions. Okay. So, for example, you've seen a whole bunch of different function calls already. So, for example, scanf and things like that. But I think most students struggle when they have to call their own functions. They find it very easy to call the standard functions, but for some reason there's some difficulty when they have to call their own. So let's just clear that up. And let's just write a really quick function just to demonstrate how it's done. So let's just do a function called add to numbers. Not very exciting, but function calls, as I said, won't take very long to understand. I'm getting messages. Sorry. Add to numbers into A, int B. And all this function does is takes two numbers and adds them together. So we'll go int z, A plus B, return Z. Now, this here is your function prototype. It basically says there exists a function below main that looks like this. Keep an eye out for it. Below main, okay, below main is the function itself. So this is doing the action, okay? It's actually calculating something. It's functional, does some function, all right? So all of the code and all of the stuff inside it's there. Now, when we have a look at our function, this top line here, or the function prototype, is sometimes referred to as the function signature. So the first part tells us what it returns, so what information it gives back to us. This part here tells us what to give it. And then the middle part tells us the name. And the name might give us some clues of what it does as well. Okay, so for example, printf is print formatted. And by the name, I can identify it and don't call the wrong function, but call the right function. Okay, so what I'm going to do here is I'm going to call the function. Now, when your function has a return type, it means that you can have this when you call it. If it doesn't have a return type, meaning it says void here, you cannot have assignment on the same line. Okay, so the other thing is I say can have. It doesn't have to have though. So for example, I could do this two ways. I could do add to numbers, and I see this quite often, and we'll work out what goes in these brackets in a second. Or I could go int w is add to numbers. All right. So this here, because it returns an int, I can store that result. Now, I've seen a lot of students make the mistake where they just do this. Now, the problem with the add two numbers that doesn't return something, you've basically gone in here, done all this work, and then gone, stuff it, don't care about the result, done, whatever, who cares? Okay, here we actually get the result and store it. Some functions you don't need to store the result. So, for example, you can actually do this. Int z printf hello. Okay, you can actually print f. It actually does return something, but we don't store what it's returned. Okay, and that actually just tells you how many characters it printed, which for most cases we don't actually care about. Okay, and that's why we don't store the result. But where it's imperative that we store the result, like adding two numbers, I obviously want the result. It's important to do this. So this is the first part of our function call. And then the second part is our arguments. Now, this is important, and this is where most students stuff up. This here requires two arguments. Okay, two arguments. So one in here, one in here. Now, these arguments are values. No matter what, they are going to be a value. Even if it's an address of, it's a value. Okay, even if it's a pointer, it's still a value. That value is a memory address or it's a data value. So here the value needs to be an int. Now, we could pass it as a literal, or we could pass it as a, so we could pass it in a variable which will be turned into a value because all it can send is a value. Okay, and that's how we do a function call. That is your function call. Does that make sense to the person that asked? Have you seen Adventures in Game? No, I have not seen it. Do not. No, I have not seen it. Sounds like I'm not missing out on much. All right, did that make sense? Kill. All right. So I think we had one more question. Is the person that had the other question? I think there's three people still here. So basically, I'm just looking for questions for anything you want to recover. So we've done for loops and while loops. It can be anything from any week. Doesn't really matter. If it's too long of a topic, I will say, and then we can come back to it. Struct pointers was something brought up, but I don't know if the person's still here. Otherwise, any topic, quiz question, blah, 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 whatever, you can raise it and we can go over it. I've still got a bit of time tonight, so I'm happy to cover whatever you like. I don't know where that thing went. I think it's on this one. Up in the quizzes for a quiz. I already have. I have. Didn't I? Yeah, I did. If you go to if you go to LMS and you go to exam, down the bottom, there's exam revision quizzes week 2 to 6. And I'll release 7 to 11 when I get a chance once you've submitted. I'll do it this week because you've already done all these. Okay, so you already can. So if you go to the exam tab, down the bottom, yeah, so it's all there. So this gives you, I think, 20 random questions. All right, it's still there. Cool. Yeah, let's do it. And it won't take too long. Yeah, it's unlimited attempts. It's not worth any marks. It gives you, let me double check, preview quiz. So it gives you 20 random questions. I don't think there's a time limit. No, there's no time limit. So it gives you 20 random questions, unlimited attempts, and you do as many times as you like. So you just go finish attempt and just as normal, and then you go submit all, blah, blah, blah. And then it'll actually tell you if it's correct, and it will give you the correct answer. Okay. So it's a little bit different than the quizzes because obviously the quizzes were marked where this one isn't. So this one will actually give you the answer and everything. Okay, so you can play around with this as much as you like. Let's go over struct pointers. So, all right, so I wonder if I've still got our struct pointer. Where was our struct pointer that we created earlier? I mean, our struct. I don't even remember if it was on the same page. Stuff it. All right, so before we had our struct student, and we had, what do we have? We had int ID. We had it says system.belt.type.belt. Do you want to go struct pointers or just want to go point structs inside of other structs? Because that's just structs inside of other structs. That's even simpler. Which one do you want to do? Let's just define this first anyway, and then we can go over either, whatever. Struction, int ID. What else do we have? I can't remember. Int. What do we have? I'm trying to remember now. ID. I know we had grade. Year level, maybe? That'll do. All right, so we've got that. Just exactly the same as before. And then we've got our int main. And then inside of that, we can do two things. So we can do our struct student, and we can have our student A. Okay. Now, remember before we had this int A here. That's the type, that's a variable. If we want to make it a pointer, we put a star at the front. So if we want to make a pointer here, we can struct student star, and we'll just call it student pointer. Okay, so this is a pointer, this is an actual student. Now, if I want to point it, I can. Okay, it just follows the normal rules of pointers. Okay, so a struct student star can point at a struct student. Remember that a struct student, add the ampersand, we've got a struct student star on the right-hand side. On the left-hand side, we've got a struct student star. Everything is equal. So then from there, what do we want to do? Okay, so as we did before, we can do something like this. Okay, we can set the ID to 17, but we can also do this. dereference s pointer dot ig is 28. Okay, so what we do here is, because we've got this pointer and our struct, which has an ID, a year, and a grade. Okay, what we can do is we can dereference this. So go here. Remember, dereference basically means just follow the line, and we end up at the struct, and then we can .id it. Now, an alternative, if you've got a pointer to a struct, you can write this little arrow instead, and that's exactly the same. The reason the arrow is handy is because you need brackets if you don't use the arrow, and some people get a bit confused about that. Okay. So the other thing that's nice is that it looks like an arrow. It's an arrow. It's yay. It's fairly self-explanatory. Now, your other question about dots and dots. Basically, if you have a struct inside of another struct, that's all the other dots are. So let's say you've got, I forgot the semicolon. Go me. If you've got struct, let's say classroom, and then you've got, let's say there's only one student in the classroom because I'm lazy. Student blah. Here, what you can do is you can create a struct classroom. Let's just call it class. And now I can go class dot student dot ID. Okay, because the class has a student inside it. Okay, so dot student, and a student has an ID, and that's all the dots are, the multiple dots. It's just getting something inside of something inside of something. And you'll see complex data structures like that quite often. Make sense? All good? Let me close this. That's Word. That's not what I want. That's LMS. You got it. The O kind of emphasizes it. No, all good. It's a great question. And it is a little bit of a complex one because we wait so long to touch structs that it's a bit confusing. I actually think it would be good to introduce structs earlier and move. It's not a bad idea. Maybe introduce structs earlier and move pointers back a little bit. Oh. Hubble or DC? I'm neither. I don't follow that stuff. So there you go. Any other questions? Assignment 3. All right, I think everyone's pretty good. Assignment 3 is done. Assignment 3, that's quiz, that's done. All right, cool. And any last minute questions? Anything quick you want to cover? I think we're pretty good. Is it possible to put the solutions for past assignment? No, but we can go through the past assignment. Do you mean the assignment 1 or 2? 1. Well, two's in marking at the moment. Hopefully it's out by tomorrow. The first year should be out by tomorrow, hopefully. The masters might take a little bit longer. Let me check where we're up to. Shoots. Assignment 2. Progress. Yeah, so we can probably get the first years out, but the masters is going to take a little bit longer. Blame BizWise. All right. In terms of assignment 1, we can go over the solution together, but I'm not going to post the solution online because I've got various reasons. I don't think looking at a solution helps. It doesn't really help. You either talk about it or you understand it and use your knowledge and your code is usually better. The other thing is I see some people just try and memorize random bits of code for the exam. And I can tell you right now, there's everything in the exam's unique. So there's nothing you can memorize. Well, other than what's called hexadecimal conversions and octal conversions. You can memorize that. All good? Any last minute questions? Are we all happy? Enjoy your night otherwise. And we might finish up there. But yeah, we'll do a last minute help session next week if needed. I don't think many people will probably go, and then I'll do a long one before the exam. So probably a day. I'll pick a day and then we'll do a long help session. But yeah. Oh, cool. Gosh, just finishing that off. All right, first year should be able to be done in the next hour or so. See ya.